Hey guys, so we're now gonna go over translation. So first, we're gonna talk about the ribosome. Okay, so eukaryotic ribosome and prokaryotic ribosome differ in their Sevberg units. So in this case, eukaryotic is 80S and then prokaryotic is 70S. Now we need to go over the fact that these units are not a measurement of mass and size. Okay. So no, it's not 60 plus 40 gets 100. These values are not additive. So the 40S and the 60S subunits combine to form an 80S ribosome subunit. Because the formation, because the complex formed by the combination has a different rate, okay, due to its new size, shape, and density. But it's not necessarily 60 plus 40 equals 100, right? So, yeah, definitely take note of that. That's definitely something that I even got caught up on. Not gonna lie, I kind of learned it like just now when I made this video. So, that's great. Okay, let's go over the mechanism of translation. So first, let's go over initiation. So small subunit binds to mRNA. Okay, your AUG is your start codon, and this is recognized by MET tRNA. Okay, and then you should know tRNA is transfer RNA, and then we should know that transfer RNA picks up different amino acids and large subunit joins. So elongation, the APE sites. And what do I mean by that? Well, the A sites is the incoming, right? So we could think of the A site as the attachment site, okay? The P site is the growing polypeptide chain, and then the E site is the exit, okay? So you can remember as A attachment, E exit, P peptide, okay? APE, attachment, peptide, exit. So termination is when a stop codon enters the attachment site. Whenever that happens, the peptide is then released. So the some post-translational modifications are folding by your chaperones, cleavage, subunit binding. If you think about hemoglobin, that's a pretty big one. Covalent modifications, phosphorylation, glycylation, and then carboxylation. Okay, so that's about all you need to know. It's honestly very simple, actually. This is something that I struggled with until I just talked through it now. Just try not to overcomplicate it. And next, we're going to go over control of gene expression in prokaryotic cells.